Ready? All right, so again, we're going to do chapter 5 first, then chapter 10. You may wonder, okay, so why are we doing chapter 5 then jumping all the way to chapter 10? Well, here's why. Chapter 5 is on a topic called classic atomic theory, okay? And chapter 10 is on a topic called modern atomic theory. And modern atomic theory really took root back in around 1923 when a guy named Edwin Schrodinger developed what was called the Schrodinger's wave equation. Okay. But before Schrodinger did that, there were a group of scientists that came up with the notion about atoms. All right. So basically, just as in a nutshell, chapter 5 discusses how much an atom weighs, and chapter 10 will start talking about the reactivity of atoms. Okay, so let's go back to the Greek philosophers a bit. There were two trains of thoughts about atoms. The first train of thoughts, and this is before any type of science came about, was, what would happen if you cut that table in half, and then you cut it in half again, and then you cut it in half again, and so on and so forth? What would you get to? And without any type of measurements or observations or anything, some of the philosophers said, well, you would get to a singular unit. All right, we don't know what that is. We can't see it. We'll never be able to see it. But there will be something there that is the smallest unit of matter. Now, another group of philosophers said that's not true. You will keep cutting, and no matter how you cut, you'll never get to the end. All right. Now, after some scientific tests and so forth in the 1800s, they found out that what had happened is you could get to the end, kind of. All right? Now, here's what classic atomic theory tells us. It tells us that the whole world, I guess as we know it, any type of matter as we know it, is made up of what's called an atom. All right? Now, inside that atom, there are three particles, general particles that we refer to in a freshman class. The first one is a proton, and the second one is a neutron, and there are their symbols. All right, a proton has a positive charge, and a neutron is neutral charge. Now, this right here is where the mass of an atom comes from. If you was to take a teaspoon of neutrons, all right, so this is going to start giving you some direction here. If you was to take a teaspoon of neutrons, it would weigh more than the Earth. 1 teaspoon of neutrons, to kind of put this thing in perspective. Now, here's what we know